So you have something like this in your Google Classroom. Looks pretty much the exact same. Notice everywhere you see these little dotted boxes. So these things, if you're on your computer, you can type right into it, and that's what I did for this first blank. If you are on your phone, it's not going to let you type right into it. I don't know why. You can treat it as a PDF, kind of like what I'm about to do, and draw on it. Or you can just submit the last page as a PDF. That's fine. So we've been talking about normal data. So this is going to kind of tie it all together, hopefully. So if data is normal, that means our mean, our median, that's what goes in this box, and the mode are the same. And if they're not the exact same, they have to be very close. And we determined that very close meant less than 1 standard deviation apart from each other. Oof. I'm going to abbreviate that. And so our very first step is identify if our data is normal. So looking at this, remember this X bar means mean. The little S, or the little sort of hat with the circle, is standard deviation. So, and this MED means median. So looking at these two, our mean and our median aren't exact, so we need to look at our standard deviation. It's 10.41. So then we compare these two. Are 82.66 and 85.03 less than 10 apart? Yeah, of course. They're like a little more than 2 apart. So that means this data is normal. So in this box, we would write yes. We also looked at it in the shape of a histogram, and we said if it has one peak and it's symmetrical on both sides, then it's normal. And sure enough, this one is too. So when we have normal data, we said we can find the normal range. So if data is normal, we can find the normal range, and the normal range is 2 numbers. We took the mean of the data values minus 1 standard deviation, and we took the mean of the data values plus 1 standard deviation. So any values that falls within these 2 numbers is considered normal. And we cared about this because 68% of data will fall within the normal range. That's more than 2/3 of our data. So those are the things we did in the past. Here's our new sort of lesson. The normal range can also be found on the normal curve. Now, what the normal curve is just an approximation of the same shape as a normal histogram. So in this blank, you're writing normal histogram. And then I want you to look right back up here where I drew this. So this is how we came up with the normal curve shape. Basically, statisticians said it's kind of a pain to draw histograms with all these little boxes, and we can approximate the same shape if we just make it a curve. And in fact, it's a lot easier to do that curve, and it has the same properties as the histogram. So instead of doing a histogram all the time, we're just going to do a curve. So the normal curve approximates that shape. Oftentimes it's not perfect, but it comes basically in a shape like this. It can be really tall and skinny, it can be kind of flat and spread out, but it looks kind of like a bell. So the height of the curve shows how many data points there are at each value. At the bottom, on the x-axis, the very middle value is the mean. All the other values are exactly 1 standard deviation above the value before. So what that means is if we look down here at this, right here, this has the most values. That's why it's our peak. And remember, the peak is your mode. And because it's normal, it's also your mean. So this value right here, 52, is your mean, your median, and your mode. If they're not exact, if your median is a little different, you put the mean here. But essentially, this is the value that has the most data points for it. So over here where it says mean equals, that will be 52. Because that's that number right here in the middle. We have 3 to the left and 3 to the right. Now, we got those numbers by using the standard deviation. So the standard deviation down here is basically the pattern that the numbers are going up by. So if I look at 52 to 58, that went up by 6. And I check 58 plus 6, yep, that gives me 64. 64 plus 6, that gives me 70. So the pattern that it's going up by is your standard deviation. So that means our standard deviation is 6. So this guy, to get to 58, I took my mean and I added 1 standard deviation. So that was 52 plus 6, and that gave me 58. You should recognize this as the high end of our normal range. So I'll put that right here. This is where it's bigger. And this guy I got by taking my mean and subtracting 1 standard deviation. So that was 52 minus 6, and that gave me 46. That's the low end of my normal range. So to find my normal range on a normal curve is actually really convenient because the normal range is always the 2 numbers on either side of the mean. So your normal range will be in this position and this position, 46 to 58. So the best way to get used to the normal curve is to draw one. So that is skill 4. The normal curve helps us visualize how spread out the data is. So the reason we care about what shape it is, whether it's really tall and skinny or nice and sort of flat like this, is it tells me how spread out my data is down here at the bottom. So as we said before, the value at the bottom in the middle is always the mean. The first values on either side of the mean are the normal range and the normal curve usually shows the values 3 standard deviations above the mean and 3 standard deviations below the mean. So we're going to use this information right here to fill in all of these blanks. So it says the value at the bottom in the middle is always the mean. The mean is represented by our x bar. So that means this one, which is right here in the middle, will be 15. So I'm going to go ahead and pick a different color. I'm going to make this 15. Now, the values next to it, here and here, are the normal range. It goes up in this direction. Just as numbers get bigger on the number line going to the right, same with numbers on our normal curve. So this number is going to be 15 plus 3, which is our standard deviation. So that number is 18. And I'm just going to keep adding my standard deviation to find these next 2 numbers. So 18 plus 3 gives me 21, and 21 plus 3 gives me 24. Now to find these last 3, these are what are coming before the mean, so they're going to be less than the mean. So now I'm going to subtract my standard deviation. So 15 minus 3 gives me 12, 12 minus 3 gives me 9, and 9 minus 3 gives me 6. So if I looked at this standard deviation, if I looked at this normal curve and I asked you, what's your normal range? It goes from 12 to 18. That's our normal range. All right, let's try one more. And we'll switch to red because why not? So again, our information is over here in the corner. X bar is our mean, 77. So that means right here, we're going to place 77. And we're going to add our standard deviation. And I went ahead and used the other symbol for standard deviation. This is standard deviation of a sample, just so you get used to what it looks like. So our standard deviation here is 3.5. So 77 plus 3.5 is going to give us 80.5. That goes in that one. And then I just continue adding the standard deviation in this direction. So 80.5 plus 3.5 gives me 84, plus 3.5 more gives me 87.5. And then in the other direction, I'm going to subtract my standard deviation. So 77 minus 3.5 gives me 73.5. 73.5, subtract 3.5 more is 70. And then subtract it one more time gives you 66.5. And if someone asked you, okay, what's your normal range here? You know it is these two values, from 73.5 to 80.5. All right, our last skill, and that's reading the normal curve. So when the normal curve is complete, like the two examples above are, 100% of all values are represented. So let me go ahead and get my marker again. 100% of all data values are represented. And we can see where most of the data is based on the height of the curve. When the normal curve is short or flat, so close to the x-axis, that means there are fewer data points at that value. When the normal curve is tall or far from the x-axis, that means there are more data points at that value. The height also shows how likely we are to see a data point at any given value. The taller the curve, the more likely it is to have a data point at that value. So what that means is, if we go back up to this one, right here, it's really, really low. There's hardly any height here at all. That means 24 is a very unlikely data point to get. Whereas right here, it's at its tallest. That's because most of our data, our mode, is right here at 15. A data point of 14 is also super likely because that would be right about here. So even though we only put these 7 values on our x-axis, all the values in between the numbers still exist. So for instance, right here is still 8, and right here still 7, and then everything in between them. But these are the only 7 points that go down here. So the taller the curve is, the more data points at that value. The shorter the curve is, the fewer data points. So here's your practice. For these first 6 questions, I'm asking you questions about this normal curve. So this is the normal curve of height in inches, and this is most likely for men. So this is the normal curve of men's heights. So 100% of men's heights can be found in this curve. So you're going to tell me what the mean is, what the normal range is, the percent of people between these two. You'll tell me if a point is normal, meaning is it in that normal range. You'll find the standard deviation, and then you'll tell me how many standard deviations above the mean someone is if they are this tall. So that's why we took the notes to begin with. And then on this one, these last 4 questions, you're going to have to use that statistics calculator again. I give you 15 values. They're grades of students who took an exam. Put these 15 values into that calculator to find the mean and the standard deviation. For simplicity's sake, go ahead and use the population standard deviation. So the one that has the symbol I just drew, this guy. And then use that information to complete the 7 values that we would usually put on a normal curve, okay? And then finally, I want you to think about whether or not this statement down here is true, using what the normal range would be for these values. All right, guys. However you want to complete this is fine. If you want to draw on it as a PDF, if you want to type in it, whatever works for you. The only part that I'm grading is the practice, but I highly recommend taking the notes, obviously, because otherwise the practice is pretty hard to do. All right, guys, make sure you get outside, enjoy some sunshine while you can.